the question, the problem solving most likely very similar as a homework assignment. So I'm going to make it as close as possible in terms of the, problem solving. Okay, any questions?
Nope.
Okay. All righty. So let's talk about this week's regarding chapter 7, work design. Okay, so in this chapter, I think majority of materials pretty much talk about how you're going to design your workplaces, and then if you're moving toward the end or second half, it talks about work measurement. Okay, you need to make sure that how your work time is properly measured, so that what kind of time is kind of average for certain jobs, so that you can record all those things for your organization. So that's something about we're going to do in this chapter, in this assignment, and relating to work measurement. So how long a particular job should have taken when things are normal, or when things are going steady pace. Okay, so that's what we try to measure here, so that we need to introduce normal distribution again from the statistics, but it's not really that bad, because we're going to just use the normal distribution score value, because you have two tails at the end, then you're going to just divide by 2, then you know what are the percentage of each position that you get. Most likely, you will fall into that particular area. So that's how you're going to determine our work will be in that particular range or not. And at the same time, you're going to decide how long this job should be taken, and we're going to make recording. Okay, so let's talk about an assignment. And here we go. Assignment number 1. Let me share my screen. Just a second. There you go. Okay. Looks okay? Can you see?
Yep.
Great. All right. So question number 1. So again, it's about work measurement. So we have this table tell you, how many minutes it's taking for certain element, certain tasks, but we have 6 cycles, 1 through 6, then we measure time, how long is taking to complete. But a couple of are missing here, like here, element 3, cycle 1, element 2, actually 2, missing 3 places. So we need to watch out that, otherwise pretty much straightforward in terms of number of minutes it taken to finish that particular element. So basically this is just recorded, what they call stopwatch time. They call it stopwatch times 30. So all you do is just record the time it's taking, complete the tasks. Then at the end, then you take those minutes and then average them. Okay, so pretty much straightforward. Whatever number of cycles you have, then take it and you find the average. Okay. So for the first element, what this first element could be, one workstation doing something else, the second element doing another thing. So we have 4 elements, but second element is different. Other element just, or you do just find the average, right? But that one, second element, because we're missing 3 cycles, so whatever you get, divide by 3, right? Not by 6. So obviously, you have only 3 numbers, so average is 1.5, right? As you can see, because we have 1.5, 1.6, 1.4. So average of 3 is 1.5. We have a bunch of numbers, of course, you need to calculate. So that's the idea here. Okay. So we found that observed time for each element is just average time as we calculate it. Okay. So pretty simple. Question number 2. So this is what I was talking about. We're going to use normal distribution because it introduced margin of error, confidence level, and assume, our samples are normally distributed. So that's where they come from. So what we're trying to do is, again, we're trying to measure our tasks, okay, how long each task or each element should take. Then how many times we need to do it. That's the problem here. How many observations we need to have. 100, 200, 300. Of course, it's better, it's more accurate if you do it every second, for example, right? Then it's going to be very accurate. But again, it's taking time, money, and all that, so we need to compromise. So that's why we come from here, precision, at the same time, confidence level, okay? So precision is margin of error. You heard it before. And then confidence level, how confident you are, how much how much sure you want to be for this particular study. 95%, 99%, that's typically 95% 5 or 99% in normal distribution. You heard about it a lot. So that's where they come from, normal distribution for this question. So standard deviation is 1.5. Okay. So that's from the mean, right? Mean time. The error term, we have error term 0.4, okay? So that's what we got here. And we have formula which we can use to find how many observations we need for this particular setup, okay? We have standard deviation, we have error term, but we have a confidence level of 95%, 5%, 90.5%. Then how many observation, how many times we need to measure, right? So here we go, n equals, here we go, that's from the textbook. N, that's the number of observation. Then you have a number of a standard deviation, which is z-score, times s, which is sample deviation, which is given in this example. Then you divide by, again, error term, which is 0.4. Okay, so we plug into this formula, then you find how many observations we need to do for this particular question. But you probably already figured that, 90.5 confidence level, z-score would be 2, okay, because it's known, right? We can calculate, but it's just widely available. We know z-score is 2, meaning that, two standard deviation of that will be placed upper level and lower level, right? So the 95, 90.5% sure that the data will be placed or found in this level between, or two standard deviation, upper level and lower level in terms of negative number and positive area. But anyway, so that's what we're going to plug in, but we need to use the value, the percentage is given from normal distribution table, right? And to find 2.0, we can use it 2.0, which is just available. But if you want to find, for example, different confidence level, then you need to go to the table. So in this example, we go half of the 95.5%, which is, what is it, 4775 or 4777. So there's 4 into here between these two numbers. So that's where it's come from, 2.0 and 2.01. Okay, so that's where we found that z-score from. Okay. All right, coming back. So that's where 2 is plugged into this formula right here. So they became 556.25. And because the percentage we found was between 2 and 2.01. So we need to calculate this as well, plug in, and to make sure we get the close number. Yes, it's very close, which is 56.81. Okay. So those are the two numbers, 56.25, 56.81. Meaning that we're going to need at least 57 observations for this study to maintain the confidence level of 95.5%. All right, and if you have any questions, let me know. Question number 3 is very similar, but this time we're going to use the same formula here. However, in question number 3, one of variable is not known, unknown. For example, we don't know this margin of error. Okay, we don't know E this time. Okay, so we need to use other terms to replace denominator, which is using sample standard deviation times sample mean times accuracy, which is 2%. Okay, so that's the accuracy that they want to maintain for the goal, and then standard deviation is 0.253. Okay, so we're gonna multiply these two numbers, then you'll find denominator in this example, so that you can replace the error term. Okay, then the numerator will be same. Okay, with the standard deviation, and then you're gonna multiply by a z-score, which is 2.57 in this example. And again, this time the confidence level is 99%. So we pretty much sure that we want a more accuracy. So but before we get into here, we need to find the mean time, because this mean is not given. So we take that and we find the mean score, which is 5.4 minutes. Then we're going to plug into our formula here, to find number of observations. First with 2.57 z-score, and the other one is 2.58 z-score, because the value for 99% is 0.495, which is half of the 99%. So we're going to find from, again, the table, z-score table, which is somewhere here, so that we can plug it. Can plug in 2.57, 2.58. Actually, the number was 495, right? 0.495. So pretty sure that that's close 36.246, and using z-score 2.58 will give you 36.52. So it's going to be 37 observation this time. Okay. So only difference is just your denominator, because of error term was not known. All right, number 4. Question number 4. So this one, I think probably you played this before in your statistics course, to assign random number. Okay, and actually in Excel, we can use random number function to assign random number generation, right? But so the direction is you're going to use this table to generate random numbers to make hour and time. Okay, so what we're going to do is we're going to schedule a work sampling, meaning that between 0, 100 to 0700, 0759, so between this hour, so we're going to make a observation. So we'll test it somewhere, but rather than doing every 10 minutes, 20 minutes, 30 minutes, we're going to assign some random hour minutes. So that's what I mean by randomly generating numbers. Okay, so that, this can be normally distributed. Okay, you want to be really random. Okay, rather than just make it, very regular numbers. So that's the idea. You're going to use this table. And to do that, we're going to use column 4. This is column 4. So we're going to use those numbers. And we're going to use row 3 to assign. So column for hour, rows, this row number 3 for minutes format. How? There's the detail. Okay. So again, the format, the hour and minute format is this, right? Must be 0, 100, 0759 between. So we're going to generate those hours between only this format. If it's like 800 is no good, okay? As long as it's within this format, this range, that's what we wanted. So to do that, we're going to use the column to generate hour. So we go to column 4, which is these numbers. So we're going to record all these numbers here. Then we look up and take only the last digit, which is 1 here, 7, 4, 4, 6 in that order. Okay, so that's the number we found. Okay, taking only last digit. Okay. However, we're going to keep only digit 0 to 7. Why? Because remember, the range of hours is only 0 to 7. So anything over 7 is no good. So we just throw away like 8 and 9. Then we're going to keep these numbers, which is 1, 7, 4, 4, which is 8 of them. Okay. So we're going to keep only first 8 hours because we're going to have like 10 numbers here. Okay. So that's how we're going to assign the hour using random table. Okay. So what we got is 17446,311. What about minutes part? Remember minutes part, we're going to have like a 00 to 59, right? So that's the format. And this time we're going to use a row 3 across. So these numbers will be used, but this time we're going to just pick it up 2 as a pair. 47, 15, 24, 86. Okay, so that's what we got. 47, 15. So we got that pair. Okay. From this, we're going to keep only those numbers in this range, 00 to 59. So 47 is good, 15 is good, 24 is good, 86 is not good because it's greater than 59, 27 is good, 76 is out because it's greater than 59. Okay, so that's the process. Then we're going to keep following numbers from step 2 here. Okay, so we got 8 of them to match the hour we found from above. So finally, that minute, the valid minutes formats are here, which is taken from here, exactly same. Then we're going to combine that hour with minutes format. It's just like that. So we're going to take 1 hour format and 47 minutes, 7, 15, and so forth. But the direction, I think the direction says arrange the times chronologically. Okay, so the earliest time comes first, which is 100, then 147, and 256. 156 and 338 in that order. Okay, so that's what we came up with random times for this question, this setup. So I'm taking few more steps, but pretty much straightforward as long as you don't lose those numbers or you don't skip some of those numbers. Okay, any question about this?
I have a lot of questions, but
Sure.
they will probably come up while I'm doing the homework. All of this it's a lot.
Okay.
But when I get hands-on, I will more than likely. Is it okay if we put our questions in the homework since it's homework? Because I have kind of done that and you've responded, but I just want to make sure that that's a good use of
Yeah.
Okay.
Of course.
Will that be counted negatively against us, or do you prefer?
No,
Okay.
probably it's better you just email me because by the time I grade a little bit, kind of a week behind sometimes. So better email me than put it into assignment.
Okay.
Yeah. Right?
Thank you.
Sure. Anything else? Okay. Any other questions? Okay. Again, I'm going to post, details about next tests. And meanwhile, if you have any questions, let me know. Okay. So we'll see you next time.
Thank you.
Bye-bye.